So in the last few lectures, we started with the we have understand the basic concepts of mechanical vibration. Then I started with the actual part of the module number 3, that is a free undamped single degree of freedom vibrating system. Now till now you might have understand what is free vibration, what do you mean by undamped, what do you mean by the single degree of freedom, and what do you mean by the vibration. So one by one we have understood all the concepts. Now it is very easy to perform tomorrow's practical. Okay. So now, what we mean by the undamped free vibration, I have already explained you. Then we have understand the natural frequency omega n. Then we have understand what are the methods of finding the natural frequency of vibrating system. The first one, the very easiest one, is nothing but a D-D'Alembert's principle. So finally, by using a D'Alembert's principle, we have got a formula called as a Fn is equal to 1 upon 2 pi square root of k upon m. So very important formula. So again, I have explained the Newton's method. By using a Newton's method also, you have got the same formula, right? Fn is equal to 1 upon 2 pi square root of k upon m. So natural frequency depends upon the k, that is the stiffness of the spring Newton per meter, and mass, that is nothing but the k. Okay, so I hope you have understand this. Now we will understand the remaining last two methods, that is nothing but the energy method. Okay, now we'll start with this. Now what energy method? Now you know that basically from our childhood we have been known or we have been studying about the law of conservation of energy. Okay, so obviously I was talking about the extreme energy as well as the, you can say, a small amount of energy. Okay, so energy can, whatever may be the energy can neither be created nor be destroyed, but can be converted into the one form to another form. Okay, so energy can be just converted. Okay, so in free undamped vibrating system, no energy is transferred to the system or from the system. Basically, try to understand. Okay, why? Basically, in free undamped system, we are just giving a small initial displacement x, right? So x is nothing but a small initial displacement. Okay, so we are not applying a continuous force in the free vibration, and in undamped, we know that there is no c. No c means what? There is no external damping. Okay, so basically, because of this, in free undamped vibrating system, no energy is transferred to the system or from the system. Means what? There is some sort of energy which gets converted into the one form to another form, right? So basically what I mean to say is that the total energy and basically the total mechanical energy remains constant. Okay, it is very important. So what is the statement? T is equal to constant. T is nothing but the total mechanical energy. The total mechanical energy remains constant. Okay, means what? No energy is transferred to the system or from the system, and that is why the total energy or the total mechanical energy remains constant. So this is nothing but a statement of energy method. Okay, what is the statement of D'Alembert's principle? Summation of inertia forces plus summation of external forces is equal to 0, and summation of F is equal to ma. This is the statement of Newton method, right? What is the statement of energy method? Ultimately, what you have to find? Ultimately, you have to find 1 upon Fn is equal to 1 upon 2 pi square root of k upon m in hertz. So ultimately, we'll be getting the same formula, whatever will be the method you study. Okay, so T is equal to constant. So total energy or the total mechanical energy is nothing but a kinetic energy plus potential energy, right? So this is already we have studied a lot in the last lectures. Now basically kinetic energy is due to the motion of the body or mass, right? Kinetic energy is due to the motion of a body or mass. So kinetic energy is given by k is equal to 1 of mx square. Basically it is 1 of mv square. It is related to the velocity, and we know that v is equal to x dot. That is equal to dx upon dt, right? Derivative of displacement. So that is why we call it as the 1 of mx dot square. Okay. Now potential energy. Now we have understood what is kinetic energy. Let us understand the potential energy. Now number of times I have explained you that potential energy is due to the two cases. Can anybody tell me what are the two cases? What are the two cases? The first is gravitational potential energy due to the position of a body or system with respect to the mean or the datum position. For example, this is the datum position. This is the simple pendulum. Okay, let us say this is the extreme position. So from extreme position to this datum position, this is nothing but a height h. So what is potential energy? mgh. So already I have explained you this in the lecture number 1, right? So this is nothing but a gravitational potential energy which is given by mgh. So gravitational potential energy due to the position of a body or a system with respect to mean or datum position, this is the potential. Okay. Second is the strain energy. Now I have explained number of times. Strain energy is due to the elastic deformation of the body. So basically, when the elastic element like beam is there, spring is there, spring. You can take an example of a spring. You can take an example of a beam, shaft. Okay, so all are nothing but the elastic elements, and so the energy stored inside them is nothing but the potential energy, or you can call it as the internal potential energy, or you can call it the internal elastic energy. You can call it as a strain energy, whatever you can call. So internal potential, internal elastic, internal strain energy. Okay. So this energy is calculated by, now this potential energy in the form of strain energy is stored in the spring. Already lecture number 1, you can find out the statement once again. Okay. So potential energy in the form of strain is stored in the spring. Now this strain energy, how do you calculate this strain energy? How do you, now this strain energy potential energy is calculated by the mgh. This potential energy is given by the area under the force versus deflection diagram. Now force versus deflection diagram means what? I have already explained you that. Let us take an example of this spring. Okay. Now let us say that you apply spring force F, you will get a displacement x. Now you know that this F is directly proportional to the x. Means what? The applied force is directly proportional to the unit displacement. Means what? Whatever according to the force you are applying, you will get a displacement x inside the spring, right? So that is why this F is nothing but a force applied to the spring. Means what? If you are applying a force to the spring, spring will either get extend or spring will either get compressed. So depending upon how you, if you are applying the force in this manner, the spring will get compressed. If you are applying the force in this manner, the spring will get extension. So extension and elongation are the two, you can say, phases of a spring, depending upon how you are applying a compressive force or you are applying a tensile force. But always this F is directly proportional to x. So F is equal to K into x. This F is called as the spring force. Okay. Now this spring force is always given by K into x. Okay. Now let us understand. Okay. Now same. I have already explained that this F is directly proportional to x. Same. F is nothing but the applied force, right? So whenever you are applying a force, there will be the extension x inside the spring, which is, so that is nothing but a displacement. So F is directly proportional to the displacement. Now, whenever you are applying a force to the spring and there is a displacement or x inside the spring, right? Let us say L is the natural length. L is the natural length means what? L is the original length. Okay. After applying the force, you got an extension of x. Okay. So total length is what? L plus x, right? So total length is L plus x, or x plus L is nothing but a total length. Now, what has happened? You draw a force diagram. Force diagram means what? On the y-axis you take a force, on the x-axis you take an extension. Extension means what? X. Now when you draw this f versus x diagram, okay, you are getting a straight linear line. You are getting a straight linear line, and this area under the curve will give you the elastic potential energy inside the string. Area under the curve will give you the elastic potential energy. So this elastic potential energy in the string is equal to work done by the force to achieve an extension x. Means what? Work done by the force. Whatever the amount of work this F is doing, so that there is a displacement x inside the spring. That is nothing but the elastic potential energy. I already explained that whenever you are applying a force or any system or any spring, okay, the work is done on that particular system, and that work done is stored in the form of the potential energy inside the spring. This is what I have explained in the lecture number 1 or 2, right? Now, how do you calculate this? This work done by the force to achieve an extension x is equal to area under the ft graph. What is that area? This area is nothing but this area. So how do you calculate this area? This area is equal to 1 of f into x, okay? Because that is a half of the fx, so this area is equal to 1 of f into x. But what is f? F is nothing but a k into x spring force. So what you are getting? 1 of k into x square. Okay, this is how I have calculated this. So potential energy or the strain energy is 1 of k into x square. Okay. I hope you have got this all these three formulas. Let us move next. Okay. Now consider a simple spring-mass system as shown in the figure. Okay. K is the stiffness of the spring, M is the mass, and I am giving a x as a displacement, initial displacement. Again remember that I am dealing with a free undamped system. Free undamped. Free means what? I am giving only a initial displacement x. Undamped means what? There is no c. No c means what? No external displacement. So this figure is called as a, see, you try to understand. This figure is called the free undamped. If I modify this figure like this and I take a C, I take a K here, I take a M, okay, and I give a small displacement X. Now this is called the free dam, and this is called the free undamped. If I modify this figure and apply the force F, continuous force F is equal to A sin omega t. Okay, so this is called as a force vibration. Now this becomes a force vibration. So basically, depend upon the nature of the external excitation and whether you are providing an external damper or not, it will change the type of the system. Okay. Let x be the small displacement given to the mass m and given the small displacement x. So what will happen? The spring will get elongated. So x will be the deflection inside the spring. So x will be the displacement of the spring itself. Okay. So now according to the energy method, total energy is equal to constant. So what is total energy? Kinetic energy plus potential energy is equal to constant. Same statement. Now what is kinetic energy? Kinetic energy. What is now kinetic energy? First of all, what will be the kinetic energy in this? Anybody? Kinetic energy is stored where? Kinetic energy is always stored inside the mass. Okay, so the statement will be like this: kinetic energy of mass m. See how to write. It is very very important. Kinetic energy of mass m translational. Kinetic energy of mass m translational. Okay, kinetic energy can be also rotational. Kinetic energy can be also rotational. But here your mass is only translating x. So there is a up and down motion of the mass. How will you understand? Based on the figure which I have shown, you can see that these are nothing but a longitudinal vibration. Mass is moving up and down along the axis x, right? So that is why this mass m is having only a translational kinetic energy. If there was some pulley attached to this mass, okay, so this pulley might have rotated by angle theta. Now you can say that there is a rotational kinetic energy inside the pulley. While solving a problem, you will understand this. Okay, so that is why kinetic energy of mass m translational and potential energy of a spring k is equal to constant. See how I have written this, right? Now, what is this kinetic energy of mass m? 1 of mx dot square. What is potential energy? 1 of k square is equal to c. Okay. Now, message me. Have you understand till here? So I can move to the next part. Now we have to differentiate. Now differentiating with respect to time t. See how I started according to the energy method. First of all, consider a simple stream mass system. Let x be the small displacement. According to the energy method, the total energy is equal to constant. K plus P is equal to constant. What is kinetic energy? Kinetic energy of mass translational. Potential energy of spring and constant. And potential energy of spring is equal to constant. So 1 of mx dot square, 1 of kx is equal to 0. Now we have to differentiate with respect to time. So how do you differentiate? Okay, so see 1 of into m constant. Now x dot square. What is the derivative of x dot square? What is the derivative of x dot square? Anyone? 1 of m into x dot square is the derivative 2x dot, right? Into, now we have to take again derivation. X dot is our velocity. X dot square is nothing but a 2x dot plus derivative of x dot, because x dot is a velocity. So I have to take dx dot upon dt, right? Plus 1 of k constant 2x into dx by dt is equal to 0. Derivative of constant 0. Have you understand? X dot square 2x into dx dot upon dt plus 1 of k constant x square is the derivative 2x into dx by dt. Okay. So now what you will get here? This 2 will get cancelled. 2 will get cancelled. So what you are getting here? You are getting. See what you are getting here? You are getting m into x. Now dx dot by dt. What is dx dot by dt? Anybody? Rate of change of velocity with respect to time. What is dx dot by dt? Anybody? What is dx dot by dt? X double dot. So it is nothing but acceleration plus k into x as it is. What is dx dot by dt? Velocity, rate of change of displacement to time x dot is equal to 0. Right? So again this x will get cancelled. So we are getting mx double dot plus kx. Am I correct? Sorry. This is basically x dot, no? Sorry, I have to about this. Actually, x dot will get cancelled. Don't get confused here. Okay. Basically, what will remain? This is 2x into dot, na? Sorry, this is 2x into dot because it is x dot square. So what will remain? M into x dot, x double dot plus k into x dot is equal to 0. So x dot and x dot will get cancelled. So remaining will be mx double dot plus kx is equal to 0. So what I am getting? X double dot plus k upon m m to x is equal to 0. Now compare with the standard equation. So after comparing with the standard equation, what we will get? Omega n square is equal to k upon m. So same answer. I hope it is clear to you all. Okay. So similarly, differentiating with respect to time, 1 of m into 2x dot dx dot by dt plus 1 of k into 2x dx upon dt, right? So what I am getting, mx dot x double dot plus kx into kx dot. So I am getting mx double x dot get cancelled as I said earlier. So mx double dot plus kx is equal to 0. So x double dot plus k upon mx is equal to 0. Comparing with the fundamental equation of simple harmonic motion, what will you get? X double dot plus omega n square is equal to 0. So omega n square is equal to k upon m, omega n is equal to square root of k upon m, and fn is equal to 1 upon 2 pi. So whichever method you apply, D'Alembert's principle, energy method, Newton's method, you are getting the same answer. Now tell me, have you understand? Is there any doubt? Have you understand all this stuff? Yes. Energy method सर्वांना समजले? Yes or no? So I can move forward to the next method. Hello? Hello?
Yes, sir.
Is it
Yes,
sure?
sir.
सगळ्यांना डेरिव्हेटिव्ह कसं घ्यायचं समजलंय का? So while solving a problem, you have to apply the energy method. You have to take a derivative. Is there any doubt in taking a derivative? Derivative is very very simple. M into x dot x double dot plus kx into x dot. This will always come. Okay. Chalo. Now Ralyeighs energy method. Now you have understand the energy method. The modification of the energy method is a Ralyeighs energy method. What is Ralyeighs energy method? It states that maximum. Now you know that I have already explained you that. Let us say this is a simple pendulum. This is a simple pendulum. Okay. So at extreme condition, your potential energy is maximum, and at this is a mean condition where at mean condition your velocity is always maximum. Na? So at mean condition, your velocity, your kinetic energy is maximum. Okay, because your velocity will be maximum at mean position, right? So here the kinetic energy is maximum. So what does this Ralyeighs energy state? It states that maximum kinetic energy at mean position, maximum kinetic energy at mean position is always equal to the maximum potential energy at the extreme condition. म्हणजेच काय त्यांचं काय म्हणणं आहे की ke maximum where it is maximum at mean position is always equal to potential energy maximum at extreme position. This is what they are saying. This is the statement. Okay, I hope it is clear to all of you. Okay, so ke max is equal to pe max. Potential energy is always maximum at extreme position. Kinetic energy is always maximum at mean position. Okay. Now consider the simple string mass system and let x be the small displacement given to the mass m. Again, see, we are dealing with a free vibratory system, free undamped. So always I'll be considering a simple example, that is a k. Obviously, when you will solve a problem, we'll apply the same concept, but in the problem the elements will go on increasing, but the concept will never change. There is a free undamped vibratory system. Okay. So now let us consider that a body is having a mass m is moving with a simple harmonic motion. Okay. Let us consider that a body having a mass n is moving with a simple harmonic motion. Means what? If I draw a curve, I will get a curve like this, a simple harmonic motion. Okay, about this is nothing but the a maximum displacement. So body is having a, this is nothing but the a, this is nothing but the t. So if I draw a output time response analysis graph, I will get a sine wave, that is a simple harmonic motion, that is a periodic motion. Okay. Now therefore the displacement of a body is given by the equation x is equal to sine omega nt. Now basically you have already derived this equation in maybe 11th or 12th standard. Whenever a body is moving with a simple harmonic motion, the displacement x is always given by ax a into sine omega into t. What is a? Maximum displacement, amplitude. What is x displacement? And sine omega t. Omega t is nothing but a theta, the angular displacement, and sine is nothing but a sine form. Here only instead of omega, since I am interested to calculate omega n, what is omega n? Natural frequency I want to calculate. Na? So instead of omega, I will take omega n. It is as simple as it is. Okay. So this derivation is also very very important. A is the amplitude of vibrations. Now let us draw a graph. What is graph? X is equal to a sine omega t. Let us say this is a mean position. Let us say this is a. A is nothing but the output. Try to understand that this is nothing but the c of t. What is c of t? Output versus t. Time, right? So now you know that. Let us say this is the point number 1, this is the point number 2. Means what? Point 1 to 2 is nothing but a one cycle. and maybe here you will have some point number 3. Okay, so point 2 to 3 is another cycle. So time taken to complete a one cycle is nothing but a time period. Okay, and let us say this is nothing but the a max. A max means what? Where you will have a maximum amplitude. So this is nothing but the a. A is nothing but A max, means it is also called as the X max, means nothing. It is, so amplitude is nothing but a maximum displacement. Na? So this basic diagram I have drawn. Okay. Now, if X is equal to A sin omega t, what is X dot? X dot is nothing but a dx by dt. Okay. So A as it is constant, sin omega n into t is what? Cos omega into t into omega n into t with respect to time t. So derivative of t is equal to 1. So omega into t चा derivative मला मिळालं नुसतं omega n. Okay. So this already we know. Mathematics is very important. Now, x double dot. What is x double dot? Cos a omega n as it is. Cos omega n t minus sin omega n t and omega n t चा derivative परत omega n. So omega n into omega n will become omega n square, right? So basic derivative, you know that. Okay. Now displacement is maximum. Now tell me, when is this displacement maximum? Now when is x max? When you will get x max? At what point when you will get x max? Displacement is maximum when x is equal to a, right? Na? Because a means what? Amplitude. This is nothing but a max. Amplitude is nothing but a maximum displacement. So this is what you have to understand. So now displacement x is maximum when x is equal to a. पण जेव्हा तुमचा x हा a असेल म्हणजे amplitude तुमचा maximum असेल त्याला आपण म्हणतो maximum displacement. Max, you try to understand that Ralyeighs energy method is interested in the maximum condition. That is why I am trying to calculate the maximum condition. So x max is equal to a. Now when is velocity maximum? Now velocity is maximum when t is equal to 0, that is at mean position. You know that at mean position kinetic energy is maximum. Means what? Your velocity is maximum at mean position, that is when t is equal to 0. Means what? At this position, that is t is equal to 0. So when t is equal to 0, that is at the mean position, your velocity is maximum. So x dot is, so put here x dot is, put t is equal to 0. So what you will get? You will get cos 0 is equal to 1. So what is x dot? A into omega n. So x dot is nothing but the a into omega n. Okay. So now I have got two conditions. One is x dot max and one is x max. So basically, for doing an analysis in the Ralyeighs energy method, you have to find out maximum displacement, and maximum displacement is equal to a, that is amplitude, and what is maximum velocity? X dot a into omega n. Okay, it is as simple as it is, not so difficult. Okay, so this is what you have got. Now let's move forward. Now we know that kinetic energy is maximum. What is kinetic energy? First of all, kinetic energy is equal to 1 of mx dot square, right? Now Ke max is equal to 1 of mx dot max square. Kinetic energy is equal to 1 of m into x dot square. So what is maximum kinetic energy? 1 of m into x dot max square. Means what? When your x is equal to x max, your kinetic energy will be also max. So what will I get formula? 1 of mx dot square max square. But what is x max? Sorry, what is x dot max? X dot max किती आहे? A square into omega n square, right? मग याच्यामध्ये पुट करा. Hello. Okay. So finally, x dot max is equal to a into omega n. Put in this formula, you are getting Ke max is equal to 1 of a square omega n square. Okay. Similarly, potential energy maximum is what? 1 of, you know that potential energy or the strain energy is 1 of k into x square. So P is maximum when x is equal to maximum. So what is x max? A square. So 1 of k into x square. So now I have got two equations. Now what is Ralyeighs energy method? Ralyeighs energy method states that kinetic energy maximum at mean position is equal to potential energy maximum at extreme position. Okay. Now guys, you have got two formula. What is kinetic energy maximum? 1 of m a square omega n square. What is potential energy maximum? 1 of k square. Okay. Now half will get cancelled. A square will get cancelled. What will remain? Remaining will be m omega n square is equal to k. So what is omega n square? K upon n. What is omega n? Square root of k upon n. So Fn is equal to, so again finally you are getting a same answer. Again finally you are getting a same answer. So we are happy. So guys, this you have to understand all the methods, but there is no need that you solve the problem by all the method. You can use any method which you are interested. So tell me, have you understand all the methods? Chalo. Tell me, DLM's principle, Newton. Any doubt you can please ask me. Have you understand all the methods? समजलं असेल तर विचारा. Is it clear? No? Yes. Hello. Am I audible or not? बोला पटकन सगळे मेथड समजले तुम्हाला की नाही? Speak up fast. Yes. Have you understand all the methods? So I can move on to the next part. Now I have to move to the next part, that is the derivation of a torsional vibration. Yes. Okay. Now whatever the derivation we have done, we have used a simple spring mass system M X K. So here the vibrations are nothing but a longitudinal vibrations. Okay, means what? The mass M is moving up and down about the axis of X, that is spring K. Now torsional vibration. Torsional vibration means what? Let me take a small shaft. This is a small shaft. Let us say disk is connected to small shaft. Now you give a small angular displacement theta in any direction. What will happen? The shaft will get twisted and untwisted. The shaft will get twisted and untwisted, and this disc will also start oscillating about about the CG. So the resulting vibrations are called as the torsional vibrations. This I have already explained you. Now I have to find out the omega n, natural frequency omega n for a system which is subjected to torsional vibration. Now omega n for a system which is subjected to the longitudinal vibration is nothing but the square root of k upon n radian per second, or Fn is equal to 1 upon 2 pi square root of k upon n hertz. Now we have to find same for the torsional vibration and same for the transverse vibration. Okay, so let us move for the torsional vibration. Okay, now consider a disk having mass moment of inertia I. Okay, suspended on a shaft with a negligible mass. Now you can see this is a disk. A disk is having a mass moment of inertia I. Okay, forget about this diagram. Don't look at this diagram. This diagram is slightly critical, but just you are try to focus on this diagram only. Okay, try to focus on this diagram. Now consider the disk. Consider a disk having a mass moment of inertia I suspended on a shaft. Let us say D is the diameter of the shaft, L is the length of the shaft. Okay, L is the length of the shaft, D is the diameter of the shaft. Okay. Now I is the mass moment of inertia of the disk. Okay. Now you know that this corresponding system is in a static equilibrium position. Now we have to apply some initial displacement. We have to give some initial displacement. Now here you are. Let us say that theta is a small angular displacement given to the disk from the mean position. That means what? You are giving a small angular displacement theta. Means what? You are rotating the disk, or you are displacing the disk by small angular displacement theta and then removing. Means what? You are just giving a small initial angular displacement. म्हणजे मगासपर्यंत तुम्ही काय डिस्प्लेसमेंट देत होता लॉन्जिट्यूड मध्ये x was the small linear displacement. Now here theta is nothing but the angular displacement. So when you are giving an angular displacement, resulting vibrations will be torsional vibrations. When you are giving a linear displacement x, the resulting vibration will be the longitudinal vibrations. As simple as it is. Okay. So now let us say that theta is a small angular displacement given to the disk for the mean position in the radian. Okay. Now let m is the mass of the disk, k is the radius of gyration meter, I is the mass moment of inertia of a disk, kg meter square. Okay, and kt. Now in linear system, let us say that k is the stiffness Newton per meter. Here instead of k, what we will consider kt. What is kt? Torsional stiffness of the shaft. It will be Newton meter per radian. Now why Newton meter per radian? That also I will explain. You know that F is equal to k into x. So what is k? K is equal to F upon x. What is F? Newton. What is this? Meter. Right? Now here, in case of the torsional system, the formula is like this: torque. Torque is equal to kt into theta. So kt is equal to t upon theta, because whenever you are giving a small displacement theta, there will be a resulting torque inside the disk. म्हणजे टॉर्क येणार आहे ना तयार होणार आहे डिस्क भोवती. मग तो टॉर्क म्हणजे काय असतो t. त्याचं युनिट काय असतं न्यूटन मीटर आणि ह्याचं युनिट रॅडियन. So that is why unit of kT is Newton meter radian. I hope you have understanding. I am trying to explain you from the basics. I hope it is clear to you because this is completely new subject to you. Okay, kT is nothing but the torsional stiffness of the shaft, Newton meter radian. So kg meter square and Newton meter per radian I have considered. Okay, now torsional vibration. Okay, now basically try to understand that. One second, just one second. Give me 1 second. Remove all this animation. Okay. Okay. Now, basically, try to understand that when the angular displacement, again look at the figure, when the angular displacement theta is given to the disk in one direction. Let us say that now this is a thing, okay? You try to understand this. Okay, this is a disk, okay? Let us say that you are giving an angular displacement in clockwise direction theta, okay? So small angular displacement to me is a theta. So this theta is a small angular displacement you have given. So this is nothing but a theta, right? So what you have done, you have given a small angular displacement theta. In which direction? You have given the displacement in the anti-clockwise direction. Now try to understand that when the theta is in the clockwise direction, theta dot and theta double dot, that is angular velocity and angular acceleration, will be also in the clockwise direction because the displacement, velocity, and the acceleration is always in the direction of the applied force. Applied force. Now, in this case, it is nothing but the applied torque. So, you are applying a torque, or let us say you are applying a couple. In which direction? Clockwise direction. So, what I mean to say is that this is a disc. Let us say this is a center point O. Okay. Apply a couple or apply a torque in the clockwise direction. Okay. So, the theta dot and theta double dot will be in the direction of the applied couple or the torque, that is displacement. Is it okay? Now, similarly, in the linear system, that is the spin mass system, what I've explained that the x dot and x double dot will be always in the direction of a applied force. Then what are the restoring forces? Restoring forces are nothing but the mx double dot inertia force opposite to the displacement, and kx is nothing but the spring force opposite to the displacement. Similarly, here in this case you will also have two torques. म्हणजे बघा इथे तुम्ही जर तुम्ही ह्या फिगर मध्ये बघितलात तर हा तुमचा थीटा थीटा डॉट आणि थीटा डबल डॉट हा कुठल्या डायरेक्शन मध्ये आहे क्लॉकवाइज डायरेक्शन मध्ये आहे and in clockwise direction means what your applied torque T is nothing but the applied torque is also in the clockwise direction. मग ह्याला अपोज करण्यासाठी there will be two restoring torques generated. There will be two restoring torques. Okay, जसं त्या केस मध्ये रिस्टोरिंग फोर्स होता. What was the restoring force? mx double dot and kx. Similarly, या केस मध्ये दोन रिस्टोरिंग टॉर्क तयार होतात which will be equal and opposite to this applied torque. Now tell me what are these two restoring torques? Okay, the first restoring torque is the inertia torque, that is I theta. So you can see this I theta double dot will act opposite to the theta. Means what? Opposite to the applied torque means they will act anti-clockwise. And second one is nothing but a torsional stiffness torque. Means what? As I said that T is equal to kT into theta, and this T is called as a torsional stiffness torque. Torsional stiffness torque means what? It will be acting on this shaft. Means what? It will try to bring this shaft to its original position, and this torque is because of the stiffness kT. Stiffness kT multiplied by theta, that is Newton meter per radian into radian. So you will get radian cancel, you will get Newton meter. So this is nothing but a torsional stiffness torque. Okay, so this inertia torque is equal to the inertia force mx double dot, and this torsional stiffness torque is equal to the spring force kx. So in linear system, spring force kx is equal to the torsional stiffness torque in case of the torsional system, and inertia force mx double dot is equal to the inertia torque. So try to remember the comparison. So what will be the direction? What will be direction? Let us say that this is a disk. If applied torque T is in the applied torque T, theta dot and theta double dot is clockwise, this I theta double dot and this kT into theta will act opposite to this, that is equal to the these are called as a restoring torque and inertia torque. This torsional stiffness torque is also called as a restoring torque. So they will act opposite to this displacement, angular displacement. Now tell me, first of all, message me, have you understand this diagram? Have you understand this FBD? Have you understand this FBD? How I have done? What is I theta dot? What is KT into theta? Please message me. Yes. It is very very important, guys, to understand. That is why I am trying to explain you in the comparison mode. Okay. So now D'Alembert's principle. What is D'Alembert's principle? Summation of inertia forces plus inertia external forces is equal to 0. Okay. Now instead of forces, I will have a torque, and instead of forces, I will have a torque. Okay, so D'Alembert's principle says that summation of inertial torque plus external torque is equal to 0. Now, guys, very very important that here we are not interested in the sign. Okay, in Newton method we have to take care of the sign convention, but here you can directly no need to consider the sign. Okay, so what is inertial torque? Inertia force here I theta double dot, because see that this I theta dot and KT theta, they are always in the one direction. The एकाच direction मध्ये आहेत, which direction? Anti-clockwise. So no need to take care of the sign here in case of the D'Alembert principle. So directly write I theta double dot inertial torque plus KT into theta is equal to external torque is equal to 0. Okay. म्हणजे जर मी लिनियर सिस्टीम मध्ये काय झालं असतं, mx डबल डॉट प्लस kx इज इक्वल टू 0, हे लॉन्जिट्युडल साठी झालं, हे टॉर्शनल साठी झालं. I theta is equal to mx double dot, KT theta is equal to kx. Try to understand the comparison, very very important. Okay. So again, divide this KT upon I. So theta dot plus KT upon I is equal to theta is equal to 0. Okay. Now comparing with the fundamental equation of motion. What is fundamental equation of motion? X double dot plus omega n square into theta is equal to 0. Okay. Omega is equal to x. Linear साठी मग टॉर्शनल साठी काय येणार? X च्या ऐवजी theta, omega n square constant आणि x च्या ऐवजी theta. Okay. So now comparing the both the equation, what you are getting, omega n square is equal to kt upon I. So Fn is equal to 1 upon 2 pi kt upon I. So linear system मध्ये काय झालं? 1 upon 2 pi square root of k upon m into hertz. Now in case of the torsional system, omega n is equal to square root of kt upon I. And in case of the longitudinal system, omega n is equal to square root of k upon m or square root of g upon m. Now guys, tell me, have you understand this or not? Have you understand the difference between the torsional vibration and this? Chalo. Fast. Have you understand the difference? Yes, clear or not? Message me fast. Okay. Now I will also explain you the energy method. Let us consider energy. Please tell me, have you understand this D'Alembert's principle? D'Alembert's principle. Newton method is also one and the same. Okay. आता ह्याच्यासाठी तुम्ही म्हणाल सर एनर्जी मेथड कशी अप्लाय करू शकतो? Yes, you can apply the energy method. You can also apply the energy method. I will take the energy method. New slide. Okay. I'll take this diagram. Control C. Layout. Okay. Let me duplicate this slide. Duplicate this slide. Okay. So control S. Okay. So now, what is the final formula you have got? What is the final formula you have got? By D'Alembert's principle, omega n is equal to square root of kt upon I. Now similarly, let me apply the energy method for this. Again, I will get the same problem. So applying the energy method. To apply the energy method, because you should able to solve by any method. Okay. Now basically, unless and until mentioned, only use energy method, or you can use the D'Alembert's principle. Don't go for the Newton method. If mentioned, then also you can go for the Newton method. But most easy is the energy method and D'Alembert's principle. Okay. Now tell me, what is what is the statement for the total energy method? Chalo, fine. Yes. Energy method the statement सांगा. Anybody? Tell me the statement for energy method. Be fast.
Total energy equal to constant.
Yeah, total energy is equal to constant. What is total energy? Total mechanical energy, kinetic energy plus potential energy equal to constant. Okay. Now, what is kinetic energy? Yeah, anybody? Kinetic energy कोणामध्ये असेल? शाफ्ट मध्ये का डिस्क मध्ये? First of all, the kinetic energy will be in the disk. कशी असणार? Translational की rotational? Kinetic energy translational की rotational?
Rotational.
Yeah, rotational. Plus kinetic potential energy of a shaft. Potential energy of the spring ऐवजी shaft is equal to C. Very simple. Okay. Now you know that kinetic energy of a disk translation is 1 mx dot x dot square. So rotational साठी काय येणार आहे m च्या ऐवजी I आणि x च्या ऐवजी theta dot square. So kinetic energy of a disk rotational is always equal to 1 of I into theta dot square. Try to understand the difference. आणि plus 1 of k into x square च्या ऐवजी काय येणार 1 of kt into theta square. That is equal to C. Okay. Linear system साठी आपण काय लिहितो 1 of mx dot square plus 1 of k into x square is equal to C. ह्याच्यासाठी काय लिहिलं मी 1 of I into theta dot square plus 1 of kt into theta dot square. You can easily understand this. Okay. चलो. Now what is the next step? Next step. Anybody? What will be the next step? Next step ला काय करतो आपण? चला. Fast. Next step.
Derivative.
Derivative. They differentiating with respect to time. So 1 of I as it is into theta dot square चे derivative 2 into theta dot into theta dot चे derivative theta double dot. आता मी पूर्ण ते लिहित नाही d theta by dt. लक्षात ठेवा हे. Theta dot square असेल तर theta dot into theta double dot. Okay. Theta dot into theta double dot. Okay. Let me erase this, otherwise you will get confused. Okay. Theta dot into theta. Okay. I think I erased all. Okay, so theta dot into theta double dot plus 1 of kt as it is. What is the derivative of theta square? 2 theta into theta dot is equal to 0. पहिलं डेरिव्हेटिव्ह कसं घ्यायचं थीटा स्क्वेअरचं डेरिव्हेटिव्ह 2 थीटा डॉट इंटू थीटा डबल डॉट लक्षात ठेवा डायरेक्टली आणि थीटा स्क्वेअरचं डेरिव्हेटिव्ह 2 थीटा इंटू थीटा डॉट हे कसं आलं तुम्हाला मी मगाशी सांगितलं. आता याच्यातनं राहणार आहे काय हाफ विल गेट कॅन्सल हाफ विल गेट कॅन्सल थीटा डॉट विल गेट कॅन्सल थीटा डॉट विल गेट कॅन्सल 2 will get cancelled 2 will get cancelled. So the remaining will be I into theta double dot plus kt into theta is equal to 0. So theta double dot plus kt upon I into theta is equal to 0. Compare with the standard equation. What is standard fundamental equation? Theta double dot omega n square into theta is equal to 0. You are getting omega n is equal to square root of kt upon I. So you are getting fn is equal to square root of 1 upon 2 pi kt upon I. Now tell me, is there any difference in the formula? So whichever method guys you apply, you can solve the problem. Is it okay? Is it okay or not? Tell me, have you understand this or not? Yes. Have you understand energy method, how to apply for the torsional system? Okay. Okay, so I hope you have understand this. Okay. Now, last but not least, I will just finish off the comparison. So from next lecture, I will be starting with the problems. So before I start with the problem, I will just try to explain the comparison. So what are the comparison? So last point is nothing but a comparison parameters. Then linear vibration and in torsional vibration. So you have to remember this. So I can make a small comparison over here within a short period of time. Okay. So what is the comparison here? Okay. So in parameters. So first parameter is let us say displacement. Okay. First parameter is the displacement. So in linear we are taking x, unit is meter. Here we are taking theta, unit is radian. Next is velocity. What is velocity? X dot meter per second. Here I am taking theta dot radian per second. Okay. Similarly, acceleration x double dot meter per second square. Okay, and here theta double dot radian per second square. Okay. Next, here inertia force oblique torque. Inertia force oblique torque. What is inertia force? mx double dot. Okay, that's a unit असणार आहे न्यूटन and inertia torque काय असणार आहे I theta double dot Newton meter. Right? Next, stiffness K Newton per meter and stiffness will be kT Newton meter per radian. Okay, so this comparison is very important guys. Okay. Next, kinetic energy is what? What is kinetic energy here? 1 up mx dot square. What is kinetic energy in torsional system? 1 up I into theta dot square. Okay. Next, what is what is potential energy? Anybody, what is potential energy? 1 up k into x square. And here what is potential? 1 up kt into theta square. Clear? Clear or not? Message me. Have you clear? Have you understand all the parameters in the difference between the linear and torsional system? Is it clear? Yes. So if you want, you can take a photo of this. If you want, you can take a photo of this also, or no need to photo. You can just remember. Okay. And last comparison parameter omega n. Natural frequency is what? Square root of k upon n and square root of kt upon r. Okay. This is the last point. Next, now very important, mass movement of inertia. What you have to remember? Mass movement of inertia. Mass movement of inertia I. Okay. For slender bar, this you have to remember. For slender bar, mass movement of inertia I is always equal to 1 by 12 n L square. For slender bar, what is mass movement of inertia? 1 by 12 ml square by 12. ml square by 12. L is what? L is the length of the bar. Second, for circular disc, because you have to calculate, na? You have to calculate I. For that, you have to remember this formula 1 of 12. For circular disc, what it is? Mr square by 2. So this is basically remember like this: ml square by 12. Mr square by R is the radius of the disc. So this is nothing but a slender bar means what? This is a slender bar. Okay, clear? And third, if it is a square plate, if it is square plate, yeah, anybody what is square plate? ml square by 6. If it is square plate, ml square by 6. And last but not least, so this you have already understand. Last but not least, okay, sphere. If it is a sphere, number 4, you are getting it is as a 2 mr square by 5. If it is a sphere, okay.